In this video, I'm going to show you how to use the dominance analysis program. Here are the buttons for the programs. Here there are two versions, and I'm going to be focusing in on version 2. I'm going to assume that you've already looked at the video for Dominance Analysis 1. That explains the technique in a little more detail and how to interpret the output. Dominance Analysis 2 differs from Dominance Analysis 1 in that Dominance Analysis 1 requires raw data, and Dominance Analysis 2 uses as input the covariance matrix between the variables in the regression equation. The advantage of that is that we can include the covariances and variances of latent variables. So while as Dominance Analysis 1 is restricted to observed variable models, Dominance Analysis 2 can perform dominance analysis using latent variables and incorporating those. If I click on the button for Dominance Analysis 2, a description of the program and all the instructions for using it is presented, and then we're going to input the data into the input values box here. Now this presumes that I've already done the regression equation in an SEM package like M+ or Levon or whatever, and I'm going to show you the parts of the output that I zero in on in M+ in order to specify the input values. So I'm going to bring up a little set of notes that I created for this. And I ran an M+ program in which there was this key equation within it, and I was predicting a latent variable y, and the latent variable y had three indicators, y1, y2, and y3, but my main interest is in latent variable y, and I was predicting that from three mediators. These are not latent variables, these are just observed variables. I have one indicator of each, and they're M1, M2, and M3. And then I had a single indicator covariate that I also included in the equation that I call Cov1. And so this is the key linear equation that I'm interested in, and I want to get perspectives on the relative importance of the three mediators M1, M2, and M3 in terms of their ability to predict or influence the latent variable y. Again, look at the video 1 for Dominance Analysis 1 to get the details. So that's the model I run, and when I go back to the input box, I have to enter down here the equation that I'm going to be focusing on. So I'll go ahead and do that. I put the control variable last, and this is the regression equation that I'm looking at. In R, the way we express regression equations is the outcome variable is on the left. In this case, it's Ly, the latent variable y. And then in place of the equal sign, it uses a little squiggly line. And then it lists the predictors separated by a plus sign. I don't put in the regression coefficients. I just put in the predictors M1, M2, M3, and Cov1 separated by a plus. So that tells it the equation. Then I have to indicate up here the number of control variables I have. And I only have one control variable, Cov1. I then hit the register input button, and that generates the syntax that I'm going to need to use. Now this is the syntax here, and notice there's a note that says that you have to paste a comma-separated full covariance matrix here that represents the covariance matrix between these five variables up here. So what I would do is I would delete that, and then I would put in the covariance matrix right here, and then I would copy that to the clipboard and paste it into R. So I'm going to bring back up my little notes to show you exactly what to focus on. So on the M+ output, there's a section called residual output, and you will see the section called model estimated covariances. These are the predicted covariance among the variables in the model, and you don't want to use this matrix, okay? And the reason you don't want to use it is because it doesn't have the latent y variable in it. This is the estimated covariances among all the observed variables, so it has the three indicators. The matrix that we want, and it's labeled estimated covariance matrix for the latent variables. Here you see the latent variable y and then all the other variables in the model. What we want to do is we want to focus in on a subportion of this matrix, the subportion that has Ly, M1, M2, M3, and Cov1 in it. And we want to go ahead and eliminate Y1, Y2, and Y3. So to save time, I went ahead and did the extraction. And this is the covariance matrix that is taken from the above covariance matrix. It has the variances in the diagonal and the covariances in the off diagonals. This is set up as the extraction of the prior matrix. Now it turns out we have to enter in the full covariance matrix, and like a correlation matrix, the covariance matrix is symmetrical. So you'll notice I have a 0.696 here, 0.696 here, minus 0.739 here, minus 0.739 here. The covariance between M1 and Ly is the same as the covariance between M1 and Ly here. So I just filled out the upper triangle of this matrix so that I can be inputting a full covariance matrix into the program. And then I would go and I would take that output and I would paste in the full covariance matrix. So this is the syntax that was generated, and I took this matrix here and I pasted it in. I put commas between everything except for the very last entry. So these are comma delimited entries, and this is the syntax here. I'm going to go ahead and copy this, and then I'm going to put it into R. So let me start up R. When I paste the syntax in, it'll automatically execute it. And then it gives you the output here. Now this output is abbreviated because I don't have the bootstrapping and I don't have the raw data. I can't do as much with the data as I could if I had the raw data available and I wasn't working with latent variables. Pretty much all I get from this is the relative importance indices. In this case, M2 is the most important, followed by M1, and then M3 is least important. These are proportional to the amount of explained variance in Ly. This was the normalized solution. I can also use the raw metric solution just like we did with the dominance analysis 1, and then I would get these in terms of the proportion of the explained variance that each one accounts for. Okay, but the important point here is that if you want to do a dominance analysis and you have latent variables in your equation that you want to focus on, it is possible to do that. All right, let me close this out. Go back up here, and that's it. Thanks a lot.